Okay, so let's tackle some of these word problems here. The first one says the length of one side of a rectangle is 4. The length of the diagonal is 5. Find the length of the other side. Well, we're all artists, so we're going to draw a rectangle. Rectangle means that you have all right angles. The diagonal is 5, and one side is 4, and we want to find the other side. Well, this is Pythagorean Theorem. I've got a right triangle, and I have 2 of the dimensions, the 2 sides, and I want to find a third. Now, I'm given the hypotenuse and one of the legs. So instead of a squared plus b squared equals c squared, I'm going to subtract. C squared minus b squared equals a squared. When you're given the hypotenuse and one of the legs, you subtract. So let's look at the values that we're given. My c squared, which is my hypotenuse, is 5. So 5 squared minus my leg, which is 4 squared, is going to give me the other leg squared. 5 squared minus 4 squared is 25 minus 16. And I'm showing every step. You don't have to show every step. So you get 9 equals a squared. And then I'm going to square root both sides. So a is equal to 3. So that's my missing side. Now, if you would have recognized this, this is actually a Pythagorean triple. So if you saw the 4 and the 5, and you saw that the 5 was the hypotenuse, 4 was one of the legs, you wouldn't have had to do the calculation. If you recognized the triple, you'd say, ah, that's a 3, 4, 5. You might not say it just like that, but you'd be close. Okay, so let's look at number 2. The lengths of 2 congruent sides of an isosceles triangle are 5. Now, isosceles, that's 2 congruent sides. So isosceles is 2 congruent sides. So what I'm going to do is I'm going to draw me an isosceles triangle. I know these 2 guys are congruent. So I'm going to say 5 meters. 5 meters. The base of the triangle is 6 meters. Find the length of the altitude. Now remember, the altitude is another word for the height. So that is at a 90-degree angle. So what I'm going to do is I'm going to draw the altitude here. So I'm going to draw the altitude. It's going to come straight down at 90 degrees. And that's what we want to find, is the altitude, or the height. Now, since this is isosceles, that means it's symmetrical. So if the whole base is 6, that means this is 3 and this is 3. Now I'm going to use the Pythagorean triple here. If I were to break these triangles apart, I'm just trying to find the height, or the altitude. This is 5 and this is 3. What do I know if I know my Pythagorean triples? The height is going to be 4. So your altitude is 4 meters, or your height. You can H or A, whichever one you want to use. Now, if you want to do it the long way, you would do 5 squared minus 3 squared equals your altitude squared, or your height. You can call it either one, A or H. So I got 25 minus 9 equals A squared. 16 equals A squared, and I don't want A squared, I want A, so I'm going to square root both sides, so A is 4. And that would be 4 meters. Make sure that you have your units. Okay, let's look at number 3. Number 3 says, what is the altitude? Here we go again. What is the height at 90 degrees of an equilateral that has all congruent sides triangle with side lengths of 6 yards? Find the area. I'm going to draw my equilateral triangle here. Equilateral means all the sides are congruent. It tells you the side lengths are 6 yards, so I got 6 yards, 6 yards, and 6 yards. I also want to find the altitude of this, so I'm going to draw the altitude, again 90 degrees, and if that's 6, it's going to separate it into 3 and 3. Okay? So I want to find the altitude. I'm going to call it A or H. If I've got 3 and 6, I'm going to separate these apart again. I've got 6 and I've got 3. Now there's 2 avenues to this. In a 30-60, in an equilateral triangle, I'll get it right eventually, all the angles are 60s. So that creates a 30-60-90 triangle. Now in a 30-60-90 triangle, the side across from the 30, you multiply that by square root of 3 and you get the altitude. So I could just do 3 square root of 3 yards, and that's it. But if you don't remember that, you can do the Pythagorean theorem. So I've got the hypotenuse again in one of the legs, so I'm going to subtract. So 6 squared minus 3 squared equals my altitude squared, or h, whichever one you want to use. 36 minus 9 equals a squared. Okay. So I've got 27 equals a squared, and I want to square root both sides. Now, 27 is not a perfect square. So what I'm going to do is I'm going to simplify this radical. I'm going to factor 27. It's 3 times 9. 3 is prime. 9 is 3 times 3. Or you could box in the 9 because it's a perfect square. So the square root of 27 is the same thing as the square root of 3 times 3 times 3. So what I'm going to do is I'm going to locate the pairs. I have one pair of 3's. For every pair, 1 comes out. And then I have a 3 left underneath all by itself. So 3 times square root of 3 yards. The other way you can look at it is 27, hopefully you can see it here, is square root of 3 times square root of 9. Well, what's the square root of 9? 3, and then 3 left underneath there. So that's another way you can do it. All right, let's look at number 4. A rectangle. So we're going to draw the rectangle again. Is 5 meters, and so we know that we got all these right angles, which means we can apply these right triangles, is 5 meters wide and 12 meters long. How long is the diagonal? Well, that's going to be our c squared, right? So what I'm going to do with this one is a squared plus b squared equals c squared. So 5 squared plus 12 squared equals c squared, which is my diagonal. So 25 plus 144 equals c squared. So 169 equals c squared. So I'm going to square root both sides. So c is 13 meters. Now, you could also skip and say, oh, I can go back up here. This is a Pythagorean triple, 5, 12, 13. Up to you if you want to memorize those. Okay. So let's do the last one on the first page. These dadgum rectangles, more rectangles. So I've got a rectangle. Again, rectangle implying that you've got 4 right angles. It's 18 centimeters long, and the diagonal is 22.2 centimeters, just because they want to give you a decimal. How wide is the rectangle? Well, that's your width. Are you going to add or subtract here? That's right, you're going to subtract. Y'all are so smart. You're going to subtract because you've got C and B, or C and A, whichever one, but you've got the hypotenuse. So 22.2 squared minus 18 squared is going to equal the width squared. Or you can call it A, or you can call it B, whatever you want to call it. So since I don't want to think, I'm going to do 22.2 squared, and I get 492.84. So I got 492.84 minus 18 equals W squared. So I'm going to subtract the 18, and I get 474.84 equals W squared. Again, that's the width. I'm going to square root both sides because I want W. So when I take the square root, oops, one moment please. If I take the square root of my previous answer, 474, I get 21.79. Now let's see if we can make that into a fraction. I'm going to hit math fraction. That's ugly. So we're just going to leave it as 27.8, or sorry, 21.8. So 21.8 centimeters. And the reason I'm rounding to 1 decimal place is because I'm only given measurements to 1 decimal place. So that's the first page of the Pythagorean Theorem application.